Okay, well, welcome everyone to continuation of the bioimaging seminar series between Janelia and Emble. Today I have the pleasure of introducing John Bogovic, who's my colleague at Janelia. John got his bachelor's from Washington University in St. Louis in electrical engineering. He went on to Johns Hopkins, where he received his PhD in electrical and electronic engineering, where he studied medical image analysis. And so he's joining us today from Janelia, where he's currently works in the Saalfeld lab, and I think he's been there for just about 9 years, actually. So, well, without further delay, John, please take it away.
Right, thank you, Mark. I'll share my screen. So today I'm going to be giving a live demo of some of the tools for working with N5 images, N5 and HDF5 and Zarr in Fiji. So it'll be fairly dry in the sense that you'll be watching me write images to files and then open them over and over again and in a bunch of different ways. So that's what it's going to be. It'll be impromptu. I have a rough outline of what I plan to talk about, and maybe I have about half an hour, 40 minutes worth of content, and then I can ask if there are some details that people would like to see more of. And I'm also interested in just having a discussion. This kind of assumes some background with HDF5 or N5 or Zarr, but if people don't have that, I would be happy to take a couple of minutes to explain that. I'll also just plug that the I2K conference is happening Friday, Monday, Tuesday, and I believe on Monday I have a talk about this topic that more motivates and describes some of the trade-offs of these formats. But like I said, I'm happy to go into that to some degree today if it's interesting, but that is also available on Monday if needed. So I guess any question, does anyone specifically want some background before I start the demonstration? I know some people some people here are definitely familiar with this. I guess another thing to say is that this overlaps. Some of the functionality I'll show overlaps quite a bit with specifically Moby, which Christian Tischer and others have developed. And in some ways, what I'll show is a bit simpler than that. We'll see what the situation is like. And every once in a while, we align our efforts to try to combine, and I hope that will continue to happen. But at least I'll show what the state of these Fiji plugins are today. So, okay. So the plugins that I'm going to show today read and write and display files in the N5, HDF5, and Zarr formats. So to get to them in Fiji, you can go to File, Save As, and Export N5. That's how I'll be writing everything. You probably won't see me go here much since I'll be using a hotkey, but this is the dialog that we'll see to write images. To load images, there's two ways of doing it. The ImageJ way is with File, Import N5, and that will open this dialog box. And we'll see this a bunch of times today. And then there's also plugins, BigDataViewer, and N5 Viewer. So these are the three plugins that I'm going to be showing today. Again, we'll go over them in a little bit more detail. Okay, so this talk is going to be just about writing images to files. So the first way is Save As, Export N5. And the main things are to give a path to the folder that you're going to write the image to. And this is a data set. And once I'm going to write this, and then we're going to look at what happened. I'm going to not touch too many options yet, but so far I'm just saying, put this image, the active image, in this place. And if I say okay, and I look here, you'll see on the bottom left here, a folder appeared, and it also appeared here on the terminal. So it made a folder, and inside that folder, it made another folder. And inside that, there's a bunch of other folders and a JSON file. And N5 and HDF5 and Zarr are all so-called chunked formats, which means they break the image into little cubes and write each little cube as a separate piece or file onto your into your folder, computer's hard drive. So actually, I'll show a quick image of what this really means. This is essentially what it's doing. So instead of, you might be familiar with TIFFs or TIFF stacks, where you have a 3D volume and each image is itself contiguous. The formats that I'm going to be showing today break the image up in this particular way. So every file that was just written is one of those little cubes. So for example, here's a folder, and then there's 3 files in this particular folder that are 3 of those little blocks. That's all that happened. And it's important that if we write them, we should also be able to load the data again, right? So we'll just make sure that what we just wrote can be opened again. And that's not what we want. All right. So right now I'm going to just, to this plugin, point to the folder, the sort of the root folder, and I'll press this button, which looks inside of it, and it found this folder inside of it, JRC18, and it noticed that it's an image of a certain size and a particular type, and it estimates how big it is in bytes. And hooray, if we open it, it actually opens and our data is there, right? So this is kind of like the minimum thing that we'd want out of anything that stores our data, that it actually stores it and that we can actually open it, of course, right? The main benefit of these kinds of storage formats is that opening subsets of them is fast. That is, you can open any particular subset without having to load all of the data, for example. At least in this cartoon, in this case, if you were to store your image as a series of 2-dimensional images and you wanted to, if you were only interested in what was in this little cube, you'd have to load all of the slices that intersect the little cube. And if your slices are enormous, this might be slow. Whereas if you store in these little cubes, the way N5 and Zarr and HDF5 do, then you only have to load usually a much smaller amount of data, and they're opening it is faster. And this is especially useful for the other plugin, which I'll show, which is N5Viewer. And N5Viewer is just a wrapper around BigDataViewer that knows how to open certain kinds of N5 files. So I'm going to do the same thing. This dialog, notice, looks just like the previous one, except there were some options down here that are missing, and we'll go over those next, actually. The process is the same. I hit detect data sets. It notices the data that's in there. I press OK, and it opens a BigDataViewer window. And this is, being a BigDataViewer window, we can arbitrarily reslice and do all kinds of BigDataViewer things. So those are the basic functionalities. We can at least write data, and we can open them with ImageJ, and we can open them with BigDataViewer. I'll have a quick pause, but any questions at this stage?
John, could you show us can you show us one of the JSON files?
Yes, that would be great. So let's look at this. Here's one of the JSON files that was written. Things to notice are, one, oops, I took a screenshot. Hi, everyone. The dimensions. So this is how large the image is in pixels, and you'll see that corresponds to this image 505, 235, 147. There's also block size here. This is the size of those little cubes that was written. You also, just important to note, or interesting to note, is that the block size, or rather the dimensions, don't have to be a multiple of the block size. That is, there will be some chunks that are not completely full with data, if that makes sense. There's also compression, so every block is compressed independently, as well as some other metadata, and this is a particular way of storing a transformation from pixel units to physical units, in this case microns. So it tells us how the pixel spacing in microns, for example. Thanks, Mark. Alrighty. So a nice thing about these plugins, and I mean the libraries behind them, and actually the formats themselves, is that they're all pretty similar. I mean, they all store data in these chunks, and there's the details of how those chunks are stored changes in small ways, but not in serious ways. And one reason that's nice is because we can write to any of those formats using this same plugin. So for example, I can just change the extension to H5, and I'll press OK. And now you see that like an H5 file is written, yeah. And I mean, I can kind of convince you that it's, well, I have to go back a little bit. So, I mean, it's really an H5 file. This is just a command line tool for looking at HDF5 files. It knows what to do, and it's the size that we expect, I guess in opposite order. So here's X, Y, Z, and it's really there. So this plugin, so far we've written to N5 and HDF5, and all we did was change the extension that we wrote to. And I guess I'll show you another, I guess, just a little bit more evidence. If you file import HDF5, this is an older way, an older plugin that Fiji uses that enables reading, excuse me, HDF5 files. And I'll just open it this way too, and we'll see that it actually wrote it, and it's understandable by other things. Yeah, so again, this is so far really simple. I'm just writing things in a bunch of different ways. And while I find this folder, I'll just talk a little bit about some of the trade-offs between some of the formats. I need to go up one more, I think. So HDF5 has been around for a long time, and because of that, it's widely adopted. So many different softwares know how to open it. So I mean, Fiji of course does, Elastic does, I mean, all kinds of medical imaging does. So here, this is again just the old plugin. It noticed that same path, and it opened it correctly. Thank goodness, right? So why would you even use N5 or Zarr given that HDF5 exists, right? I mean, it's more widely adopted. And the reason that N5 and Zarr exist is because it's been difficult to write in parallel to HDF5 files. And part of the reason for that is that it is one file. So you'll see here, this is just one file, whereas this is a directory full of a bunch of files. And the fact that this is a lot of files makes, again, just writing to these in parallel very straightforward. Writing to H5 files in parallel isn't as straightforward. And years ago, when we were processing a large amount of data, we wanted to easily be able to write to these chunks in parallel. And so our group developed this format. And around the same time, the Python community developed Zarr, and it solves this same problem in pretty much the same way, in that it writes these chunks as separate files. And I'll just prove to you that I can write Zarr files here too. I'll just change the extension to Zarr. Nothing else changes. I'm going to press OK. Yep, folder popped up, and we'll look inside of it. Look here. So yep, same kind of thing. And the only difference is, whereas this has this sort of nested folder structure that N5 does, Zarr kind of packs them all in this one folder with a similar kind of scheme for deciding indexing the chunks. So it's the same kind of idea. And all of those formats are writable from Fiji if you would like, and they're all readable from Fiji as well.
John?
Yes,
Is that still the case? If with Zarr, I thought you can also have folders instead of these dots.
you can. That's exactly right.
Okay.
Yeah. Zarr can read N5s as well. I'll show that actually later, but you're exactly right. If you'd like, you can write a Zarr with this nested folder structure. Yep. But as I understand it, the default looks like this still.
John, I
And
noticed one. I
please go
noticed
ahead.
one. I noticed one flaw in when you open the H5 didn't carry over the pixel size, and I kind of know why that is. But do we have a way of loading the H5 where it would also capture the metadata?
Yeah, it's let's see. It should. So I think so it's in here. It's just in here in a sort of sneaky way. And I think if I'm understanding you're pointing out is when I opened it in this way, file import HDF5, yeah. So
Correct.
this expects the metadata to be called a certain thing and located in a specific place. And the way I wrote the metadata in a different way. And so I guess this speaks to just the lack of standards for metadata in these chunked formats, which is a problem. We'll talk about that later, though. I mean, if it's of interest, we can talk about that later because we can talk about that for a long time. And I mean, Christian knows that there's been a lot of conversations about this, and the community is working towards a standard, and I'm very excited about that standard becoming more widely adopted. Yeah. Okay. Next, I'll just show some of the other small features that are more, I guess, show more of the advantages of these kinds of formats, albeit in like a little bit of an artificial way. And then maybe I'll show something real afterwards. So specifically, what I claimed earlier was that writing and reading subsets is faster and easier with these formats than in others. And so I'll show examples of that. So first I'll show writing. First I'll show reading subsets. So for example, let's say I just am interested in this area here. Yes. So this, oops. I'm a little bit stuck. Okay, so this point is about at like pixel location 192, so I'll round that up to 200. This one something like 3. Yeah, so this we're at 250, and we'll say 300, 100. So if we open this and if we click this crop button, once I hit OK, another dialog box is going to pop up, and it's going to ask me what subset of this data I want to open it. And I don't remember what I said, but I'm going to take a guess. I think it was, we'll say it was something like this. And I hit OK now, and it opens, and there's some, yeah, so I wasn't quite correct, but this, like, you can believe me that this is the right subset, and actually this is something that I should fix. I want this origin to be reflective of the fact that we didn't open starting at 000. So I'm going to fix this because I don't like the fact that this image doesn't know about its relationship to this image. So John found a bug during the live demo. Wonderful. So that's one example. It's also possible to write subsets of data into an existing image. So I'll now just write some subsets. First, I'll show the fact that I'll change this back to N5. If I tried to write, so this option is just helping me to be safe. If this says no overwrite, it's not going to allow me to write data into an existing data set. So if I hit OK here, for example, it should, well, I would have liked for it to complain to me, but maybe it did. I'm not sure. boy, I hope it didn't write anything. But next I'm going to allow myself to overwrite some things. So first, let me just do this. I'm going to do something a little bit silly. So I just grabbed a little subset from the middle of this image. And now I'm going to write it into the existing data set. So this says I'm going to overwrite some subset of the original data set with this. Oops. That was strange. And this will let me specify where in like the offset of this image in the larger data set where it should go. So for example, I'll say 150, 0. And I'll hit OK. And of course, I'm going to try something different. Let's try this. Okay, I don't know what I'm doing. Let's see what happened. Let's see if it actually did anything new. Okay, I messed up something. John's going to try this again later. And what this should do is if I open this again and I wrote this at the origin, I would have wanted this opening the image again would have resulted in a copy of this displaced here. So if I opened it again, I would have wanted to see this image as is, but this block would have contained the image content here. And this is easier to do with code. And when I do this, I usually do it with code, but it is a capability, or rather should be a capability of the plugin. And of course, it just didn't work for me now. It did work for me yesterday, though, on a different machine. Christian, yes.
How does that work with the chunks? I mean, you know what I mean? Like, I mean, yeah. You're muted.
Yeah, thanks. It has to be careful. You're right. So sometimes, for example, there's probably a chunk here that is entirely contained, like given the fact that I said, write this image into this area, like this top left chunk, for example, would have, I could just completely overwrite with the data here. But somewhere here, there's going to be a chunk that is partly overwritten by the subset that I was trying to write into. And I think this is what you were getting at. Yeah. So what it does and what it should do is read chunks that aren't entirely written and only overwrite the part of the chunk that is contained with the thing to be overwritten. So okay, you should see it behave the way you would want. And the downside is it can't just read. It can't only write. It has to read some chunks in order to not lose data. Exactly.
Yeah, makes sense. Mm-hmm.
Yeah. Okay.
John, I just noticed a question from John Milkey in that chat. He's asking about about the metadata and kind of what the best practice is for us to adopt. So I guess you showed us a little bit of the metadata, the JSON, and you showed us in the H5, and I'm assuming we would find the same thing in the Zarr. What's your current outlook in terms of reconciling all this and making everything work together?
Yeah, I think what I would say is, at least I would like, if he and others here are willing to be slightly early adopters, I would recommend going with the OME Zarr or OME NGFF metadata standard. So it's here. I need to make these plugins work with the standard, but it's, I think, only a small amount of work. And I think I'll have some help, hopefully, from friends at EMBL. But this standard is at 0.4, and I hope there'll be a 0.5 out. But you can look at what the specification is here. And I guess this is what I would recommend. And this has support for multi-scale metadata and pixel spacing and many other things. So I think this covers a lot of what most people need. And if in looking at this, you find that you don't need much more than what is here, I guess I would encourage people to use this because it exists and it will become more widespread, and more widespread means the plugins that I'm showing today will soon support this as well. Yes, thanks, Mark.
Yes, I think this is only specified for Zarr itself, right? But I think it's close enough that we probably could port it to H5 and maybe even put it in something that looks like your JSON files for N5.
Yeah, that's entirely true. I intend to use essentially exactly this metadata for N5s also, and I think you're probably right that having this in HDF5s would work well. I guess Christian or someone else, do you know if this has been done already actually?
Sorry, I was a bit, can you repeat your question?
You're muted.
If these,
I guess, is it, have people used this metadata standard in formats that are not Zarr, like HDF5, for example?
I wouldn't know. I don't.
Okay.
No, yeah.
Constantine, and, great. We can't hear you, unfortunately.
Meanwhile, I think Bill had a question about partial block writes, and if there's a transactional issue, if you have multiple threads trying to work on the same data set. So how do you make sure that more than one worker or thread doesn't try to open the same chunk and write to it simultaneously?
Yes, that is the developer's responsibility. And right now we let you be irresponsible. And we, if you use methods in, at least on our libraries, that could cause potential conflicts, it is your, i.e. the developer's responsibility to not run them in parallel. All right, Constantine, maybe?
Yeah, I mean, I think the closest is probably over the Open Organelle data standard, right, which has sort of some mix of this metadata. I mean, it's not exactly sort of this coordinate transformation, but it's fairly similar, done by Davis, and is sort of using this hybrid of N5 and MISA metadata.
Yeah, that's a good example. I'll show some of that since I have it up. So here's an example of what that might look like. I think I want to go here. Yeah, so here you'll see this field, multi-scales, is very much like an OME NGFF metadata standard, slightly modified, but I mean, the point is that if in here we look at multi-scales, this has a description for how multi-scale metadata look like. There's a multi-scales thing, and then there's data sets, and then inside of it, there's a description of the transformation. And essentially the same thing is going on here, multi-scales, data sets, and then inside there are transformations and paths, and that just the transformation, the way the transformation is described is a little bit different here than here. And yes, thanks, Mark. Okay. This is great. I like conversation. So any other questions now?
I think one thing I discussed with Davis is whether some of this metadata belongs to the data set or potentially to the group that's in. I think that's maybe one discrepancy between NGFF and Open Organelle. But I think that's resolvable at some point.
Yeah, there's ongoing conversations about that in GitHub issues. So, all right, cool. I'll also, since I'm here, I'll just show that it's possible to open these images from Fiji as well. So now I'll open this data set with N5Viewer. So this copy Fiji link is what I clicked, and now plugins N5Viewer, and I just paste it into here. This is going to take a while. I mean, it's going to take a bit of time since it has to talk to Amazon, and it looks at the directory structure in there, essentially what I showed here. It looks at all of the folders in here, and there's quite a few, and it opens a bunch of the JSON files that are inside, and it tries to parse the metadata in each of them. And so it finished. It took a little bit of time. This uses multiple threads, so it's a bit faster when I'm not on this laptop, but it's still not super fast. Moby and others have gotten around this in a nice way, but that's at least how this plugin currently works. I guess the point is now that you can see that this has a lot of data sets, many of which are pretty big, so couldn't possibly fit on this laptop. But if using BigDataViewer, I can open them anyway. So I'll just pick a couple of things. We'll just open 3 things. And now it's asking Amazon to send the data over, and here it is. And another thing that these standards don't have that I think like Moby does, for example, is how image appearance looks, so brightness, contrast, color, and so on. So I'm just going to have to set these by hand. But here you see what I think here is a light microscopic image. And then we'll see what this is. Here's an EM image. I'll turn this off and yeah, it's multi-scale. So once I zoom in, and then it takes a second to load higher resolution images, and then we'll display them once they're ready. So this is a nice feature of chunked file formats, because this wouldn't be possible, at least not that I know of, with a traditional file format like TIFF, for example. Okay, let's see. I'll show two others. I'll show 2 other small things, I think, and then I'm gonna maybe open it up to a larger discussion if that's okay. So the first thing that I think I'll show is a small demo. And I said earlier, this is just a little bit of fun. You know, in the Python world, there's Napari, and Napari and Python support Zarr quite well, and they don't support N5 so well. And what I mean by that is, I mean, the Zarr library can read and write N5s, but you know, Zarr mostly focuses on Zarr. So I think what I'll show now is I'll show an image in Napari, and then I will write it with Zarr, and then I'll just read it with Fiji. So, so we'll say, I think I need, okay, so first I'll just read some data. I think this is what I want. Good. Do I need to, I think I need to do this. If there's Napari experts, just check my.
I don't think you've imported Napari yet.
Yes, that would be good. Do I need to, I think this is fine, yeah? Or do I need to go Napari.viewer?
I think we might need to create a viewer.
You can just call Napari.view.
The Napari.view?
Image, or
Yeah,
view
that
image,
view
I
image.
think.
Yeah,
View
Napari.view
image.
image.
Yeah, this is sort of the that does this internals already of creating the viewer.
Nice. Yeah, there we go. Beautiful. Thank you, guys. So now I'll just say zarr.save. I'll call this cells.zarr, and I'll save, I think I was cell, yeah. All right, great. So now we have a cell. Hooray. And so I told you, you'd be watching me just write images and open images over and over again. So here we go. And so here we have a Zarr image again. the same image that we were looking at in Napari and ImageJ also. Okay.
John,
Yes.
is there some way of doing this with metadata or not?
Yeah. Not cleanly. At least I don't know of a way that we'd have to write the Python code. I expect this is in some of this might be in
There's
OMI. Exactly.
Right? Which is the clean way of, if you want to write the NGFF metadata, then you would use OMI instead. I mean, it doesn't have such a clean API yet as pure Zarr, but it's getting there.
Yeah.
Okay.
So maybe we can get a link to that in the chat too. That would be great. Thanks. Yeah, so I'll just show one more thing, which is software, I hope, will become more and adopt these formats more and more, especially where it's the most useful. So like I'll show an example using BigWarp, which is a tool that I write and that I use a lot for image registration. So I'm just going to do a silly transformation of this image, and then I'm going to write it to an N5 file. And this is going to be a little bit contrived, of course, because this image is not that big, but I'll explain why this is important, or I'll try to explain why this is useful as I just make a silly little transformation. So ordinarily, when you write a transformed image, you will allocate a bunch of memory that contains the entire, like all of the pixels that you have transformed. And then you apply the transform and you write it into the memory that you allocated. And then all that memory that you allocated, you write it to disk. And if your image is huge, like that 1 terabyte image of EM, for example, you're not going to be able to do that because you probably, at least I don't have a workstation with a terabytes worth of memory. But what these formats enable you to do is write, at least do the processing chunk by chunk, and then write each chunk. And that reduces the memory requirements significantly. So what I'm about to show you what it does is essentially what I described. So this will transform the image chunk by chunk. So it will allocate a small cube. It will apply the transformation so that the destination image, the transformed destination image, is in that cube. And then it will write that cube. And then it will repeat the process again for every cube that it has to. And this means that the amount of memory that you need is equal to the memory that you need per chunk, and then the number of parallel workers that are doing the transformation. And this makes it possible to apply the transformation, for example. And I guess I hope that more tools in the future will, I guess, adopt this since data are becoming larger and larger. So we see there's this warped, oops, wrong one. Yeah, so so BigWarp, I guess, is one tool that uses this this kind of chunked storage as a paradigm, like in its guts, and it enables you to do things that you couldn't do without these kind of chunk storage formats. So it's 1040. We can talk about other things. I can mention some things that I didn't do yet. I can talk about some of the code. Specifically, I use ImageLib2 a lot, so I could talk about how I interact with these formats using ImageLib2. I could talk about more metadata. So for example, how you could write your own custom metadata to these formats. I could talk a little bit more about the metadata dialects that exist. And let's see, there's also a scripting language called JQ for processing JSON files that I like for modifying metadata and working with these attributes.json files. And so I could talk briefly about that as well if it's of interest. So I guess we can also just discuss whatever, which I would be happy to do. So
I think I'm kind of interested in discussing the metadata since we discussed that a few times during your presentation, and I'm just really kind of interested in how we're going to make that all work together at some point, because I think you've shown us a pretty good demonstration of that we can move pixels around, and I think that's a lot better than where we were at some point. Looks like Christian looks like another question as well.
yeah, maybe you could go ahead.
Same question. Actually, like I had a very concrete thing, because I think I think this OME-Zarr, I guess there's a clear roadmap, right? There should be just one standard, and I hope everybody will just use it. But I was now seeing this, wondering whether we should already now push a little bit more the tooling that the same metadata that we have would also work with H5, because this was not really on my radar, and I'm not sure if anybody is actually pushing that or writing code or whatever.
Yeah, I mean, I also can't wait until the OME-Zarr is more adopted, because then, a lot of what makes my life hard is just images are opened incorrectly because some piece of metadata is not there. And as soon as the standard is really more widely adopted, I hope that all of our lives will be easier. And I completely agree that it would be nice. I mean, it will be easy to have the OME-Zarr standard just moved into N5, but HDF5 will be harder. And I agree, and I hope that we'll be able to make that work too. Because Mark, with his sharp eyes, noticed that the old HDF5 plugin didn't open the metadata right. Go ahead.
Yeah, just sort of, I mean, I'm not aware of the Fiji side, of course, but in principle, I mean, what do you see as barriers of mapping this to HDF5? Because it should support all of this in its attributes functionality.
Yeah, I think so. One thing that's a little strange about at least what the plugins that I showed are doing is that the structure that's in a lot of that's in some of the metadata are just included in a hacky way in HDF5. So if you see that this transformation is essentially a JSON file as a string in this HDF5 group, and that's kind of strange. So I see you guys nodding, which is good. And this, I don't like this, and there's surely a better way of doing this, and we just have to agree what the better way is.
Yeah, I mean, I agree it's strange to have this JSON encoded, but I mean, it supports arrays, this HDF5 dialect to write this metadata, right? So is there a reason not to just sort of use this as sort of a, however you want to call it, right, a key value store where the values can also be arrays?
For arrays, it's fine. It's just this is an object with keys and values at a particular key value.
Yeah, you can't put JSON metadata in HDF5 metadata unless you do some transformation of the JSON to make it essentially not JSON anymore.
You would have to translate the struct from JSON. And JSON is not informative about what the actual types of the primitive elements are, because it has a limited set of types. And so you either define a struct outside in a more stringent type system, or you don't. And that's why we went with this hacky route.
You can't count on the container to enforce the schema definition of the metadata. That's always going to be defined by one schema that lives on GitHub somewhere. So that seems fine. Like, you don't want HDF5 to raise type errors. Like, you want the type errors to be handled by an application.
I mean, I guess this is probably getting pretty technical, but for at least what we have in OME-Zarr, I don't really see issues with mapping it to this metadata attribute dialect of HDF5. Because we know, right, for each field, what types are allowed there.
Have you specified this in the spec?
That's a good question, right? I think a lot of this is still implicit, right? That's a part of the problem. I definitely agree, right? Sort of a lot of the spec is kind of written with, right? Whoever worked on it, either Josh or me or so on, try like knowing what's meant. But yes, things need to be more explicit in there, 100%.
Yeah, I think one challenge to me looks like the attribute tree is, has a hierarchy in it, and I'm not sure how well that maps directly into some of the HDF5 attribute structures. I think there is kind of maybe kind of group data, but I'm not sure if like the HDF5 attributes are designed to be as hierarchy like this. I might be wrong.
And what's the problem with just it being a big string apart? I mean, I don't know. At least it would be 100% the same as in the other one. So this is
and that is how it lives on disk. Like the file system doesn't validate that your JSON list doesn't contain a string. On the file system, it's just a bunch of bytes, and in HDF5, it would be just a bunch of bytes.
Well, strings are long in terms of bytes.
And what?
And they also have like a precision loss when you have double numbers and stuff like that. So it's actually nicer to store UN64 as UN. Well, with the int, it's not really a big deal. But if you have a float 64,
this was this.
Store this as a native float 64 or according to some standard instead of a string, which loses precision.
But if the dominant format is JSON, then
for some people,
well, yeah, whatever the spec decides. If the spec is using JSON, then dumping a blob of string into here is identical to.
And that's precisely what we did with this H5 thing. So the only problem unfortunately I came late because I had a scheduling clash here. The problem that you probably ran into is that the HDF5 support for N5 doesn't implement a specific JSON-ish interface, and then things don't work as you expected. But it could do that because we only later introduced that hack that you find so icky, that it writes JSON into string fields when there's no obvious native counterpart for things. And it's maybe a good idea to just have an out-facing facade that is exactly that JSON interface, and with that you would be everything should be fine. But maybe John and me should discuss this in more detail and get it to work.
Okay, but indeed, I think there was this. What Matt brought it up several times, that maybe, and you said it now again, that maybe we don't want to have everything in pure JSON, but some scaling factors maybe as a float array or something, right?
And that's what the HDF5 backend is currently doing. So for everything primitive, for everything array, it's using primitive or array. And then as things getting more complicated, it's just let's just JSON string it. And from outside through the API, you don't really notice this. So if you ask for individual attributes, but I'm not sure what the situation for the give me all of this as a giant JSON object does at this time.
Oh, I see. But we will have the same problem in Zarr then, maybe, or because
with this already factored in, right? I mean, there is sort of for these transformations both supported. You can either just store this thing in JSON, or you can give it a path to Zarr array data, where you can then have it. It's not really made use of yet because we only have pretty primitive transformations where it's probably not so important, but for sort of more complex things that John is working on, this will be pretty useful.
Okay.
There is something called BSON, and I'm wondering if that would be useful, because I think it's somewhat interchangeable. It's meant to be interchangeable with JSON, but it is a binary format. It's an ASCII text or Unicode text. and that might be useful in, say, encoding kind of these floating point numbers without losing precision.
We could use protobuf. It's pretty cool.
Yeah, well, I think BSON does kind of mention at least protobuf as well. So I think protobuf is a Google technology. It's open source. Is that right? And earlier, Davis, we were talking about kind of whether the metadata belongs at the group level or the data set level. I think you had some opinions about that and where the current NGFF format is. So that.
Yeah, I'm not
Constance here.
happy. I'm not happy about that.
So where would you rather have it? Or?
Well, I would follow common sense, and metadata that describes an array should live with the array. That would be my opinion.
And so I think the current format, if I understand, the current NGFF specification kind of assumes that within the same group, the arrays would be pretty similar or something like this. Is that the problem?
Well, the problem is that there is no declaration of metadata for the individual arrays. It's all at the group, which I think is, that it can be nice if you're trying to minimize the number of pieces of metadata you touch. But I think the way we think about images is that there is an image that has properties, and Zarr lets you express those properties as metadata of the image or array. And so for me, it's most intuitive if the metadata primarily lives with the thing it describes. So metadata for arrays or data sets should live with the array or the data set instead of putting everything up at the group. And the real consequences of this are that in reality, like when you're opening data, you're opening an array. You might use the group to find where the array is, but you're going to open an array. And you want the metadata to be right there with the array. You're going to copy arrays, you're going to delete arrays. The metadata should be right there so that when you copy and delete, the metadata moves too. But this wasn't something that was actively discussed prior to the latest spec. I only noticed it after the spec was written. So it's possible that there was just some miscommunication.
Yeah, I mean, it has pretty much historical reasons, right? That this all is based on Josh Moore's first draft and then expanded, and this is how it was designed. I mean, I think there's, yeah, I mean, the current spec really thinks about handling everything as a multi-scale image, right? So it doesn't reason at the single array level. It sort of always, you need the sort of group data, which defines these different scale levels, which then have the array data. But as, I mean, Davis points out, right, this means it doesn't really allow you to load an individual image without first looking at the group metadata. And I personally don't find this such a big issue because, yeah, I mean, it's more like a software question because I don't think you should move things around in there without knowing where they live. But on the other hand, I also wouldn't see it such a big issue to copy out some of the, or move out some of the metadata into the arrays. It's rather a bit more tricky how this decisions get made right now. But there is a pretty long GitHub discussion about exactly this topic opened by Davis. I think it's really more on a level where discussing this here doesn't make, I mean, it's good to discuss, right? But sort of the decision making really needs to be synced a bit with Josh, who's the sort of the mastermind behind OMI and GFF. And I think there needs to be some improvements to the process of how these decisions get made. But it's probably for sort of an upcoming call in NGFF to discuss.
Yeah, well, I think it's good to compare notes, and I think it's it's kind of a window for everyone else to kind of see kind of how this process is kind of unfolding. I think we have a lot of the players here in terms of looking at this kind of format. So it's kind of interesting to me kind of see how the specifications get written, and we're kind of also have things like open organelle where we're actually implementing this as we go. And
maybe along this line, I think we as developers of the tools that read and write these formats actually have control over this, because in the end it boils down to what the user does with it. And in the ideal case, the user would just drag an image onto Fiji and it will open. So whatever the entity is that users can drag and drop onto Fiji and open it, users will also copy and move these things around. So it kind of depends on what Fiji can open as a single entity, what will happen on the user side. So I think, yeah, users are lazy, and if they find out that they can copy, the second level of Zarr and 5 directory directly into Fiji and it will open, they will use that as an image file, whatever they understand that is. And this will be the basic entity, no matter what we define in the spec, it will be what the users do.
Yeah, I completely agree. I think part of my thinking and discussing with like people locally and elsewhere are just so learning to interact with images in a slightly different way, in the sense that for the huge images that EMBL produces and that Janelia produces, you don't want to have to download a terabyte in order to work with an image. And I think users will want to have the image locally because their experiences so far are that they work with images that are locally, and working with anything that is not local is difficult. Yeah, so I think software developers, like the software developers here, need to make the experience for things that are not local as good and as seamless as things that are local. Is there another comment? I think. I guess we're also at 11, so like last minute for comments, I suppose. But this was fun for me, as a little bumpy, but it was fun. I appreciated all of the discussion. So thanks everyone for participating too.
well, thank you, John. One last question, actually. I noticed you're using a scale offset filter here. What's that for?
Sorry, say that again.
I noticed you're using a scale offset filter in your HDF5 list here, and I was just curious about what that was for. Kind of filter -0
yeah.
at the bottom there. Yeah.
I don't recall. Stefan, do you remember?
Probably default.
Yeah.
Because I think that that shifts and kind of scales and multiplies the data, basically, if I understand what it does. So it's a kind of interesting thing. It can change how well your data compresses, and so that's just an interesting filter to have in there. But okay, well, I think with that, let's conclude. Let's thank John again for doing an impromptu talk. He signed up to this about a week ago, so so I think this is kind of great to put together. But thanks again, John, and thanks to everyone for coming.